Hey there, my fellow intellectuals. Dr. Kyle here with another video. Tonight, we're going to be looking at a problem that lived rent-free in my head all week. My coworker at lunch showed me this problem on his phone. It was a multiple choice question, and I looked at it and I didn't give it much thought, but I couldn't figure it out at the time. I was thinking maybe it's like one of these two answers, but I was so wrong. And I tried to solve this problem and I had the most difficult time before I realized what the trick was. This is one of those trick problems that you got to know the trick to make some headway. Don't do anything fancy like I was trying to do, like, oh, maybe I just multiply things by, a clever form of one, right? So maybe you can multiply it by like the conjugate, right? Like this, right? And make it some fancy form of 1 or something, right? So this is just 1 here and trying to eliminate the things on the denominator. No, 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 no. Don't do that. Don't do that. That's not a smart idea. It will just lead you to more pain and misery like it led to me. So, if that made sense. So how do you actually go about solving this? Well, the thing is, one needs to recognize that it would be very convenient if you could write this in the form of the square root of a plus b squared. That would be very convenient because the square root would just cancel the square and you would just be left with 1 over a plus b. That is sort of the pipe dream that you would love to happen. But what if I told you that pipe dream can be a reality, okay? It could actually be a reality. So we need to recognize here that a plus b squared, if you expand that, you can rewrite that as a squared plus b squared plus 2 times a times b, right? Because if you do the whole FOIL business, right, if you expand this out and then you do your old nice FOIL first, outer, oh, that's not an outer, outer, right, that's AB, inner is BA, and they commute, so that's 2AB plus b squared, right? So hopefully we know this, because knowing this is going to make our life so much easier. And the way to do this is to look at the denominator, look at this 2005 plus the square root of 2005 squared minus 1. And we're going to say this is all equal to a squared plus b squared plus 2ab, because that's our pipe dream. That's our pipe dream. We want to think that we can rewrite 2005 plus the square root of 2005 squared minus 1 as this sort of perfect square, a plus b squared. So we want to somehow map these two sides to each other. And for convenience sake, I am going to cleverly pick this to be the 2ab. Now, why I'm going to do that is going to make much more sense as you see what's going to happen. Note that 2005 squared minus 1 can be written as the following: 2005 plus 1 times 2005 minus 1. Okay, so if you, again, do the FOIL business, right, you get 2005 squared, you have a 2005, a negative 2005, you have a positive 2005, which will cancel this one to give you 0, and then you have a plus 1 and a minus 1, which will give you a minus 1. So hopefully you can see that that's justifiable. So the square root of 2005 squared minus 1, we can write this as the square root of 2005 plus 1. That's just 2000 and, oops, sorry, that's 2006. Sorry. 2000, and I'm just going to draw it here, 2006 times 2004. And that's just going to equal, like we said, 2 times a times b. And what we can do here is we can use the property that the square root of a product, ab, is just equal to the square root of a times the square root of b. And so we can write the square root of 2006 times 2004 as the square root of 2006 times the square root of 2004, which is equal to 2ab. And now we can divide both sides by 2 here, okay? But we're going to do something, again, kind of tricky, Because remember, 2 you can write as the square root of 2 times the square root of 2, okay? And so what we're going to do is we're going to stick a factor of square root of 2 underneath the square root of 2006 and the square root of 2004. If we stick that here, we can rewrite this as square root 2006 over square root of 2 times the square root of 2004 over the square root of 2, which is equal to AB. But notice here that, again, we can rewrite the following. The square root of A over the square root of B is just equal to the square root of A over B. And so what we can do here is write this as the square root of 2006 over 2 times the square root of 2004 over 2 is equal to AB. And so what we have for A times B is just the square root of 1003 times the square root of 1002, which is equal to AB. So we can say that this is our A and this is our B. Wonderful, because again, like I said, we can rewrite the original expression as just 1 over the square root of A plus B squared. So we know what A and B are now, right? Because the denominator was just the denominator is now just going to be 1 over A plus B, where A is square root of 1003, and B is the square root of 1002. So we can rewrite 1 over 2005 plus the square root of 2005 squared minus 1. That's just equal to 1 over the square root of 1003 plus the square root of 1002. Now that's not quite one of the answers we had, which has now magically disappeared. Oh, there, here are the answers. I guess I put it on a different page. But we can already see we have one answer that is a square root of 1003 minus 1002. So it looks like that would be the answer. But let's just go ahead and just verify that is indeed the answer in the proper form. The way to do this is just to multiply by the conjugate now, like so, because this is just a fancy form of 1, right? Because square root of 1003 minus the square root of 1002 over itself is just 1, so this is the same expression. And what we're going to get on the numerator is a square root of 1003 minus the square root of 1002. And then on the denominator, we'll just do our FOIL again. So root 1003 times root 1003, that's 1003. We'll have outer, so we'll have minus root 103 times root 102, and then the third term is the inner, so that will be root 102 times root 103, no, 1002 and 1003, but these will cancel. And then the last term will be just 1002, right? So it's actually going to be minus 1002 because we have a positive root 1002 and a negative root 1002. And so we'll have 1003 minus 1002, which is just 1. And so the denominator is just 1. And so the final expression will just be root 1003 minus root 1002. So there you go. That problem lived rent-free in my head all week, and now it has been kicked out and evicted. So with that, that'll conclude the video. I hope this was a nice refresher on how to handle these kinds of problems. Follow my channel and subscribe if you want more content like this, and I will see you in the next video.